Okay, here's problem number 2. It says, what is the pH when 15 milliliters of 0.2 molar HNO3? So we know that this is a strong acid, so they'll probably have neutralization going on. Added to a buffer that contains 50 mils of 0.25 molar HCO2H and 0.3 molar NaC2H. So what I would start with is the equilibrium that's occurring in the buffer. So you take the weak acid, HCO2H, which I think is formic acid, and we show adding it to water, and it losing an H to the water to make a hydronium ion, and then the formate ion, CO2H minus. Again, the sodium we don't care about, that's a spectator ion. And so this is an equilibrium, and we could figure out how much of each thing that there's going to be. That would be helpful. So there's 50 milliliters of this, and it's 0.25 molar, and there's 50 milliliters of this. They're sharing the same container, they're mixed together, and it's 0.3 molar according to this. And so 50 times 0.25 gives us 12.5 millimoles of the weak acid, and 50 times 0.3 gives us 15 millimoles of its conjugate base. And then writing out the neutralization reaction, if we're adding a strong acid, we only care about the H ions. And then we say, okay, does the H ions react with this thing? This is a weak acid. Or does it react with this thing? This is a conjugate base. So we know the acid is going to neutralize the base. So the H ions will react with the CO2H minus ions completely to make HCO2H. And then it depends on stoichiometry to see how much is there. So the H ions, there's 15 milliliters, and it's 0.2 molar. So 15 times 0.2 is 3 millimoles of the strong acid that we're adding. So we can go ahead and look at the equation for the buffer. The hydrogen concentration equals the Ka times the acid over the base. And again, the Ka comes from the HCO2H, so you'd have to look that up. And that is 1.8 times 10 to the negative fourth. And then we set up our fraction here of acid over base. And we go back and say, okay, this was the acid, and there was 12.5 millimoles of that. And this is the base, and there was 15 millimoles of that. And when we add the strong acid, it's going to bring the conjugate base down 3 millimoles and result in the acid going up 3 millimoles. So how can I erase this? If I circle it, how did that mess everything up? Ah. Sorry. Okay, I'm not sure how to erase this. Okay, so we're saying, I gotta go back to the pen. Okay, so we're going, this is the acid on top, and we're saying that's going up by 3 millimoles, and this is the base on the top, and that's going down by 3 millimoles. So we're ending up with 9.5 over 12 as our fraction times the 1.8 times 10 to the negative fourth, and that gives us our H concentration. So then we can just negative log that to get our pH, and that comes out to be 3.63. Okay, I think we're done. Thank you.